fire safety management. And we need to look at the roles of facility managers in managing the fire safety, or better put, in managing the fire risks of each facility. So when I say fire risks, it's not into what we call the risks of fire. How likely can fire happen? If the fire happens, how seriously can it get things damage, assets damage? Could there be loss of life? And if the answers to this is actually yes, if the answer to this is actually yes, then we can then look at the mitigations. How can we reduce either the likelihood or the severity, of the fire events? And so that will take us slightly into what we call the fire emergency planning and what we need to do. I'm driving. Don't mind me. I'm driving, but as soon as I can, I'll get a place to park so that I can actually give you more info that give additional seconds or 1 minute, to people. Then I'll be back. All right. Okay.
We can't hear you again, sir.
Yeah, good evening, sir. We can't hear you.
Same here. Hello, sir. We can't hear you.
I think he went on a short break.
Oh, okay.
Okay.
Am I on mute? Hello?
They're back on.
Hello?
His network is bad, though.
Wow, the
We
network
can't hear you at all.
really bad. It's terrible.
Hello?
Sounds like you are singing, sir.
Mr. Collins?
Hear me, please.
Yes, it's clearer now.
Okay, thank you.
Welcome back, sir.
Okay, so pending the time we are waiting for our facilitator. So there will be a discussion among us. Is fire a friend or our enemy? So I would like us to raise up our hand to discuss whether yes or no, if you think fire is a friend or an enemy. So who is going first? Do you all get the question?
Yes, please.
No, sir.
Okay, Mr. Mike. So, Mr. Mike, can you please start and discuss? Is that you choose a friend or enemy? Can discuss. Thank you.
Oh, can't I choose both?
You can start with one. We can discuss. Yes. Let's see. Anyone?
Okay, so starting with fire being a friend, we looking at the way. Let me start from the home. We use for those of us who use gas cookers at home, which I do. Depending on how you manage it, you are able to use your fire for your cooking, for getting your beautiful and great delicacies out of the system, and have your whether breakfast, lunch or dinner. For those who are at work, that use who deal with welding equipment, we know what we do with oxyacetylene gases, and we know what we can get from it when we use your burning torches and your equipment. So in that light, I'd say it's a friend. But when it comes to being an enemy, if the equipment, in the case of again the gas cooker, if it is not used, maintained properly, and possibly there's a leakage of some sort, and there is a simple spark in a space where that gas has been exposed, or it leaks out, then at that point it becomes an enemy. In the case of an electrical fire, if there is wires touching or bridging in a place where it should not, and it comes in contact with combustible materials, fire at that point will never be your friend. So that's it for me for now. Talking about friends and enemy, fire being a friend or an enemy, it can be one or both, depending on how one manages the situation. Thank you.
Okay, Mr. Michael, we appreciate that. Thank you very much for that. Mr. Samuel, I can see your hand up. Can you pick it from there?
Good day, everybody. Good afternoon.
Yeah, good evening.
Good evening, sir. Yeah, basically, we all know fire is our friend when it comes to usage, what we did it for. It only becomes our enemy when it's out of control. I think I'm clear enough. You understand?
Okay. Yes, thank you for that, Mr. Samuel. Do you have other person? Thank you for that. Any other person? Or should we start picking names? Hello, Juniela. Mrs. Mubo. Good evening, ma.
Good evening, sir.
Yes, ma. Ma, can we hear from you? Is fire a friend or an enemy? So that's the discussion for now.
Like what everybody has said, it has the negative side, it has the positive side. And it's when the positive side is not well managed, it becomes it becomes something that is absurd, something that is out of control. So I say in the two ways, it has its advantage and it has its own disadvantage. So it depends on the context we're looking at it from. If it's in the facility, it needs to be managed well so that it doesn't come to the disadvantage that buildings have to be maybe burnt or what's it called, diesel not managed well, generator not well oiled well, for it to come into hazard becoming fire incident. So it depends on the content we're looking at it. If it comes to domestic, the fire is good for cooking. So it depends on the way we look at it, sir.
Okay, thank you, Mara. That's very good. Mrs. Titi Lokwe, good evening, ma. Mrs. Tokwe, can you please unmute yourself and share something about the discussion?
Hello, good evening.
Yeah, good evening. Thank you.
Yes. Yes, I just joined, so I heard about the advantage and disadvantage. I'm not too sure about the question.
Okay, so the question is fire a friend or an enemy? So that's what we are discussing.
Okay, I think I will also join the previous answer that says it's both our friend and enemy. If it's not well handled, it can be the enemy. But definitely fire is our friend if used for the right purpose. Thank you.
Okay, Mr. Kwe, thank you very much. Really appreciate that. Okay, Mr. Tsilade, good evening, sir.
Good evening, Mr. Kolako.
Okay, welcome, sir. So
Yes, sir.
you're able to hear the question. So how can we control fire at home? Like, how can we make fire not to be an enemy? Let's take it out.
Okay. I'll refer back to the last class of Friday. One of the things I could pick from it is that it is essential and highly important for us to note that our 12.5 kg cylinder should not be in our kitchen, even though I'm a culprit of that, that we should have an extended hose that leads out of our kitchen and the cylinder should be outside. So it means fire could be a friend and at the same time it could be an enemy, depending on how we handle it. So if we handle it very well, it gives us the very best of it. But if we are careless, we would always see the other side of it. I hope I have, said something meaningful. Thank you. Hello.
Thank you very much. Really appreciate that. That's very insightful.
Okay. Thank you.
Sir. Yeah. Hello, Mr. Gary. Good evening, sir.
Yeah, good evening, sir, and good evening, everyone.
Okay, thank you. So,
yeah, okay. Fire is both friend and enemy, because according to everyone that said people that said something earlier, fire could be a friend if well managed, because it's being used for so many things, for cooking, and if we tend not to handle it well, it becomes an enemy. That means it goes out of control. So fire is both a friend and at the same time, let me use this word, foe. Because you don't manage it very well, if we are being careless about the usefulness of fire, it can become very dangerous, and then goes out of control and then becomes our enemy. So if it's both a friend and at the same time an enemy. Thank you so much.
Okay, thank you very much. So right now we're discussing, is fire an enemy or a friend? So now, what is fire? No, we talk about fire, we know what's. So what is fire? Can somebody define fire? Mr. Pascal. Hello, Mr. Pascal. So what is fire? Hello, Mr. Daniel. Okay, Mr. Samuel, do you want to say something? Mr. Samuel, your hand is up.
Hello.
Yes. Hello, Madam Juliana. We can hear you. Okay, hello, Madam Blessing.
Good evening. Good
Okay,
evening.
good evening. Good evening, ma'am. I will tell you. Good evening, ma'am.
Fire is a burning sensation.
Can I say something?
I say something.
Yes, it's a country. Yes, we are all saying something. Yes, we are all contributing to
Okay,
it.
I think fire is the process in which any substance is being combined with chemical and oxygen from air, and you typically give out a bright lead, or maybe like a heat, smoke, and it will cause combustion.
Okay, thank you for that. Thank you. Another person?
Further to what she said. Hello.
Yeah, you are with you, sir.
Yeah, it's a process. It's a process for me. Fire is a process in which substances chemically combine with oxygen from air. Do you understand, sir? So to bring out a form of combustion or burning, like she said, but substances combining chemically with natural oxygen, like air, to cause any form of bright light, heat, combustion, or burning. Do you understand, sir?
Yes. We got it. So any other person?
Just came out.
Hello, Mr. Matthew. Mr. Matthew, can you have your opinion on what is fire?
Good evening, everyone. Can you hear me?
Yes, good evening, sir.
Yes, this is Mr. Matthew. I can define fire as a process whereby elements are being combined. Elements such as oxygen, heat, and fuel combining together to give a chemical reaction in an exothermic process. Did you get that?
Yes, sir.
Hello.
Hello,
All
Mr.
right.
Matthew.
Yes. So is it a combination of the chemical element that is involved, where oxygen and what heat to give a chemical reaction? Thank you.
Okay. All right. Mr. Bamdele Obaya, can we have your opinion on that?
Hello, good evening, sir. Good evening, everyone.
Yeah, good evening, sir. You're welcome.
All right, please, can you come again with your question, please?
Okay, the question says, what is fire? You know, we've discussed, is it a friend or an enemy? So right now, what is fire?
I just got into the class, so for me, fire is a chemical reaction that forms with air to produce heat and flames. And it can be in different form, and it comes in different color, as the case may be. So basically, it's the form and the approach it takes. It depends on the chemical that formulates the whole thing. So that's what I can say from my own point of view, because I've not actually read about it, but the concept of fire is quite well known to every one of us. A combination of chemicals combined with air, depending on the usage and depending on the environment at that particular time.
Okay, thank you very much. Please, I would like us to rename ourselves to our name, people of attendance, because we are saying we're Y7. So that we have to know people in class.
Okay.
If there's any time we're joining the class, let's make sure it's our name.
Okay. Thanks everyone. I think we can actually close the class. Seems everybody's a fire expert, and so what do you think? All right. Thanks for that interaction. So fire. Yes, loud and clear. I've heard you. I can say half of the class is actually knowledgeable about what fire is, and so maybe what we just need today is a top up. All right. So fire, yes, is. I heard somebody say something around exothermic. I would have loved, to ask the person what he understand by exothermic. That's giving off heat, thermal, giving off heat into the environment. So the heat being given off is external, is thermal. So it's actually key that we all understand what fire is. I also like that fact that we know that fire is not just a friend, but if not well managed, I think management is the key word there. So if not well managed, fire can then become an enemy. So let me just jump into this. That by definition, I think we again have here some definitions actually sound theoretical, but the truth matter is fire again is the process by which substances that can burn. So we say flammable substance or flammable substances, things that can burn actually burns. So when they come together in the presence of heat or ignition source, and of course oxygen, keyword in the right proportion. So I repeat, fire is a process where combustible substances or element or material, come together in the presence of ignition source or what we call heat, and the right proportion of oxygen. So that's between 16 to 21%, to give off heat, light, smoke, soot, so those are like the outcome or the output of that fire process. So there could be heat, there could be light, there could be black soot, especially if there is incomplete combustion and what have you. So fire is a friend, yes, but in this case and for the course of this class, we are actually looking at fire being an enemy and how we can turn this enemy into a friend. I say it again. Or look at a case where fire is actually a potential enemy, but we limit the potential, that enmity potential, and only enhance or maximize, the positive side of this. So what we're here today is to think about it, is to dwell about it, is to know what the concept is actually all about, to ensure that as much as we can within our capacity, this is actually well managed. So the management of this concept is why we're having this presentation. So it has to just happen. You need to master fire. You need to know why and what can lead to fire in your premises. I had somebody talk about work, well-trained activities. Fantastic. So as FMs, the first question we need to answer is the fire is not a class of fire. It's a source of ignition that can lead to fire if, for instance, there is partial contact, if there's wire break, if there is overloading of that socket, if there is undersized cable being used in that facility. So things are really very key that we just need to mastermize. We need to understand what it is. You don't just have a facility, maybe they need to wire the facility and in a technician. So I want to look the quality.
Mr. Colaport, the line is breaking. Can barely hear you.
Probably use that specification and you make so what of the cable is in use? Why are we using what we're using? You ask questions, guys. Fire can happen from wiring of the house, right? Fire can happen from the way when I say wiring out, so it could be either conduit or surface wiring, even without you talking about bridging or joining the cables. So the design phase. So we need to understand what it really is. And so secondly, we then move to the quality of the work.
So it's not just about the quality of the material, but the quality of the handsman, the quality of the technician. So if he doesn't know what he's doing, guys, we're in a mess. Somebody came to my facility yesterday, and supposedly the person is coming to do the building safety audits, and the guy cannot even ask the right questions. The guys that came could not even, speak to my facility engineer about what he needs. So definitely, when we have that discussion this morning, is a fail. We can't give a job to that kind of guy. So the first thing is you need to even know what you're looking for. You need to study. You need to drive this. You need to ask questions. You need to know. You need to be talking from the position of knowledge. You need to know, guys. You need to know what you want. It is when you know what you want, then you can ask the right questions, even if the experts are brought into the system. Fire. If you bring in contractors, and that's one of the worst things. If I can remember, we've lost factories, we've lost facilities because of contractor safety management. Guys, if you work with contractors, when I say contractors now, I mean vendors, suppliers, people that come to work in your facility, other companies that come to help you fix things. Those are one of your weakest links, guys. These are the guys that can actually mess you up. So if you work with contractors, you need to be on top of the game. Health and safety, fire safety, you need to be on top of the game. The Japanese company Benin plant got burnt weeks before commission in 2001. Burnt from, I mean, everything got burnt. The machine, everything they lost everything. A new plant that was just constructed or reconstructed as it may, and they were awaiting commissioning. And somebody came in to do some hot work. Burnt, it might not be intentional. That actually got the whole factory, new factory, burnt. Million factory burnt just because of one hot work. I know some of us bring people to work. Some years, I think just before 2019, if I'm not mistaken, at 4 Points by Sheraton, before you get into Lepto Gate, after about one building, 4 Points by Sheraton, there was an accident right in there, gas welding. Of course, life was lost. And of course, the facility, the hotel was not burnt, but it gave them very serious negative media reputation. So guys, we can't afford to have a repeat of this. We can't afford to have we can't afford to manage a facility, a school, even an hotel, work in a factory, in a simple workplace, and have fire happen. So what can we do? Fire safety management. Write this down. 4 things you need to know when it comes to fire safety. 1, fire prevention. So we call it fire safety management strategies. 1, fire prevention. And fire prevention happens by education. What we're doing right now is called fire prevention. Is when you enlighten, when people know what can cause fire and what they need to do to prevent this from happening, and how they can be a part of safe, fire system. So fire prevention is one aspect that's very key. 2, fire protection. So fire protection most times come via design. Maybe your facility, your office, you want to bring in new buildings, you want to get new equipment installed and things like that. The first question I would ask is, have you done your fire safety assessment? What exactly did you do? Who told you that the likelihood and severity is acceptable? What kind of activities are you going to be having? For those activities, what is the flammability range of the substances? a lot of questions are asked in fire safety. But the amazing part, so let me say the bad part. The amazing part is that most of us just get things done. Most of us just jump into things, without asking those right questions. Most of us just sign off, even as managers, as authorities, without doing what we need to do. Basic principles. There are three things that must come together before fire can happen. And that's what we call the elements of fire. The elements. So you hear things like fire triangle. So by the word triangle, we mean there are three sides to fire. And one is the fuel, which I said must be combustible. And for you to have combustible fuel, it can exist in three phases or three stages. One is the solid, liquid, and thirdly, gaseous state. So the state of phase that you can have fire can be solid, liquid, or gaseous state. So in any of these three states, I can tell you for free that when what we call the fire point is reached, fire point is that temperature at which fire will burn and be sustained. It's different from flash point. Fire point is that temperature at which the fire will actually burn and that burning will be sustained. Every material has its fire point. Every material has that temperature at which things will actually go wrong. Secondly, we talk about the ignition source, which is basically the temperature. Again, this temperature must be well managed. At times, it could be so hot that we can have what we call self-ignition. By the word self-ignition, it means that the substance can combust. The substance can ignite even without presence of ignition source, which means that the atmospheric temperature, the temperature of the environment can actually ignite that substance.
Please, Mr. Kolapo, please, we can't hear what you are saying, sir.
I'm here, I can hear you. Can you hear me?
We can't hear you clearly. It's too.
So what was the last thing?
The volume is too low from your hand.
Can you hear me now? Okay, let me move my nose mask. Sorry.
Thank you.
Okay, let me move my nose mask and see if I can raise my voice. So can you hear me now? Is it better? Is it better? Hello?
Yes, sir.
Hello?
It's better. It's better.
It's much better.
Better now.
Okay, sorry. I was using nose mask before. Okay, so I was saying that ignition temperature is the temperature at which that material will burn. Is more or less the heat. So there is the heat source, which means the source of ignition, and there's what we call the ignition temperature. So your match, your lighter, your spark from electric cables, your sparks from the exhaust of an engine, whether generator or what have you, are actually ignition source or ignition sources. But the ignition temperature is now that temperature. That's at what point can this substance ignite, and at what point can that ignition be sustained? So if it is the point at which the ignition, the substance, the combustible substance will ignite, that is called a flash point. It will flash. It will flash. That means there will actually be spark, but it won't be sustained. That means it won't burn for long. But when we say it has reached its fire point, then it has reached a point where that fire needs to be quenched. And lastly, is the level of oxygen. Fire again is a living thing. Fire without oxygen, fire can be suppressed. So, but the oxygen again must be in the right proportion, not just oxygen for the sake of oxygen. That should be oxygen between 16 and 21 percent. So next slide, please. Next slide, please. I will need to move faster. Okay. Thank you. Okay. Next slide. I've spoken about this. Next slide. Just press next. I've spoken about this, the TV states. Next slide. Okay. Pause here. So, what do we then need to do as facility managers? One is to understand how this fire could start, how it could occur. And two is to prepare to respond. How the fire could start and why and how you should then respond. Okay, so how will you respond? First is you need to understand the layout of the facility. I was telling you, was on Friday last class that right now I'm more of an ESG guide and EHS, so I do more of sustainability than even health and safety right now, because health and safety is now submerged. So health and safety is just one of those things I need to deliver on. It's no longer my only focus, but of course it's my main focus, you know. And then yesterday I was having a Tuesday, I was having a session with my team as regards forklifts and what have you. And even though the place is well illuminated, and I put it to them straight up that I have a layout problem here. I can't separate people from moving forklifts. And if I can't do that, then the possibility of forklift eating someone is very high. I just joined in December, yes, but I've been here for 3 months and we need to just make things happen. So what I've just said is that you need to first understand the layout. You need to understand where the exit door is. You need to understand if you have even an emergency exit door. We've seen buildings where you only have one door. So the question we then ask is, if fire happen close to that door or such that the exit, the only exit, which is also the entry area, is blocked, what are you going to do? What are you going to do? So understand the layout, understand how your building is structured, understand how to get out of that building. It's only when you understand that you can make others to understand. It's only when you know that you can show the way to others. It is, please let's stay on mute. It's when we've understood the layout of the building, then we can then equip the building with the right fire strategy. The other time I want to tell you something about the 4 strategies for fire safety management. I did mention fire prevention, which is actually what we're doing now. There's what we call fire protection, where you do the safety in design. When you factor in safety into your design, simply put, the material of construction, what you are going to use to build that space, you should ensure that in your thinking, you also incorporate the hazards that could emanate, the hazards that could exist in that space based on the activities that you want to do in that space. If you want to have a place that should be meant for chemical storage, I bet you should build that place with concrete block, I mean, at the minimum, and not some other materials that could allow penetration of heat, that could even catch fire so easily. Protection of the space through the design, through the material of construction, through the elements of suppression that you are going to introduce is very key. And I've mentioned suppression now. So there is fire prevention, there is fire protection. There's what we call fire suppression. Fire suppression is simply the automatic means of putting out fire even when nobody is there, or the automated means. I don't want to use the word automated though. So let me stick with automatic. Okay, so the means by which fire can be extinguished automatically when some elements are detected. E.g., when the room is too hot, the bulb around the sprinkler system, overhead sprinkler, the bulb should feel the heat and break off. And if that bulb should break, it will then cause a short circuit of the fire pump system, which will automatically tell the pump to actually start. So there is a signal is sent to the panel to start the pump because there is the short circuit already. And that short circuit will have been because the sprinkler system in that building has detected excessive heat that has made the red bulb on the sprinkler to get broken. In some other cases, it could be even the FM200 that has, double check system. So you're going to have smoke detectors linked in two parallel to the FM200 panel, so that if a smoke detector detects heat or smoke, it will discharge the FM200 until the second line or the second leg of the detectors confirm it. How do I mean? So you have two smoke detectors in a room. If one detects fire and goes off, it will not activate the FM200 because it could be a false alarm. All right? But if the second one also detects that same smoke or fire, the FM200 will then be automatically discharged into the room. That is an automatic, not automated now, that's an automatic system that ensures that even without human intervention, the room or the facility is protected. Mostly used for the servers and the IT room, the data center. Then we have what we call the firefighting. And it's not the firefighting that we have the emergency response. So I said for your strategy, there must be prevention, there must be protection, there must be suppression, and there must be firefighting. So use your either the water truck, that's your fire truck, or fire extinguishers, or whatever falls under the firefighting. And for you to use, because it then needs human intervention, and that means you have to have a team that are well trained to respond to fire. Sir, if you don't have 2 out of these 4, your facility is about to burn. I'm sorry, I'm not a prophet of doom, but if 2 out of these 4 that I just said now, prevention, protection, suppression, and firefighting, if you are not ready for at least 100% or 2 of these 4, you are just sitting on gunpowder. You are treading on a landmine. It's just a matter of time. It's a matter of time to lose that asset. It's a matter of time to burn that factory, to burn that space, to burn that office. It's just waiting for the right moment, right? So what can you do? And that's why we're here. We said you have to be familiar with the layout of the building. You have to equip that building with either the suppression or the detection system. Detection system is what can help you detect the fire when it is still small, when it's growing, and raise the alarm for you. So that's your smoke detector. Suppression system is the sprinkler, the FM200, the argonite, the nitrogen, or whatever, the CO2, whatever you're using. That's the gaseous state to help you suppress the fire. You need to equip the building with the right detection, suppression, and firefighting systems. Let me deliver another bad news. If you don't have 2 out of these 3 in place, fire is about to happen. Maybe I do a recap. I said there are 4 strategies: prevention, protection, suppression, and firefighting. I said that for you to be safe, you need to have 2 of this fully in place. Either everybody is aware of what can cause fire, the triangle, the oxygen, the ignition source or heat source, and the foil, and they know that these 3 elements must not come together. Where there is foil, there must not be ignition. Oxygen is constant, so leave oxygen. Oxygen is for you to survive in that space. As human being will breathe in oxygen, right? So for you to be in that space and not be wearing an oxygen mask or a self-contained breathing apparatus, NCBA. It means that there is sufficient oxygen up to that 15-16% that can survive life. That means fire can survive in that space. So what you have left, what you have control over, is either the fuel or the ignition source. I said the fuel is in 3 states: solid, liquid, or gas. It must not exist if there is ignition, meaning that if you are welding, which is hot work, there is spark, there is release of oxygen and everything, then there must not be gas or petrol or even solid like foam, that's mattress, foam, clothing, cotton clothing close to that place. If it's the other way around, that you've got the gas, there must not be ignition source. I did hear somebody say this evening, that last week Friday we spoke about your gas not being in your kitchen. Yes, sir. It's because of this theory, which is 100% practical, that where you have your gas, you can't have ignition source. Again, emergency response or firefighting. I hope I'm not too fast for the class. Strategies are prevention, protection, suppression, and firefighting, right? The elements are oxygen, heat, and fuel, combustible fuel. I said that for the 4 strategies of prevention, protection, suppression, and firefighting, you must have 2 in place that are working 100%. For you to say yes, we are trying. The ideal state is to have the 4, but in most cases, people have 3 out of these 4. But I'm even saying that if you have 2, there is a progress, right? Then I said that under prevention, people must know that oxygen, fuel, and heat cannot come together. That's the 3 elements of a fire, and you must break them. Then what am I saying? Oxygen is constant. For you to be there, then that means there is oxygen. So the only thing you can control is either the fuel or the ignition source. I said the fuel can also be in 3 states, which is solid, liquid, and gas or gaseous state. And I said that you must separate, you must isolate the from the fuel. So if you have gas or you're using gas, don't let the gas be in the same location with the ignition, with the fire. For 2 reasons. One is the fact that the fire triangle must be broken. That means the fuel and the gas, the fuel and the ignition, that's the gas and the fire, cannot be in the same room because of leakage. If there is hose leakage, then you are in soup because the ignition is there already. But the bad part is the firefighting, or what we call the emergency response. When there is gas leakage, the most effective way to control gas leak is to shut the valve, is to lock the supply. As much as there is supply of gas, the fire will never go out. You can ask any firefighter. The fire will never go out. No matter how you blanket the fire with foam, with your maybe aqueous film foaming foam, HFF, or whatever you're using, this cannot, until the gas is locked out or it's finished burning. So this is the trick. If your gas cylinder is outside your kitchen and there is fire, you can, especially if you have that luxury of space, because I know most of us stay in Lagos. No, you can go out of that kitchen to lock the gas. And as soon as you lock the gas cylinder, the only gas that will burn is what is left in the hose, in the pipe. Then the fire will go off automatically, unless there's another material that is burning. So there is the control on the valve, on the gas, the control valve on the gas edge. So the idea of having the gas outside is for emergency response and not just fire prevention. So that even in case there is fire, you can shut that valve outside and you lock the gas in the cylinder and the fire will stop. You can even break the hose outside. But if that same cylinder is in your kitchen, I'm very sorry, it's a sorry case. So you need to equip the building CO2 DCP extinguisher, smoke detector, sprinkler system, good layout, and what have you. 2, train the workers. People must know how to use the fire extinguisher. So it's not enough to have the extinguishers. If you don't know how to pull the pin, if you don't know how to aim at the base of the fire, if you don't know how to squeeze the lever, if you don't know how to swing from side to side, that's past method to operate a fire extinguisher. Then you don't know anything. It's as good as you don't have that fire extinguisher. What we need to do right now, in fact, after this class, is for you to go on the YouTube and Google how to use how to operate a fire extinguisher, or how to operate a portable fire extinguisher. You must know how to operate this. Otherwise, we are in soup. Otherwise, if fire happens, we won't be able to respond. And the last one is for you to assign roles and responsibility to staff before there is an emergency. What do we mean? For emergency response, people must know what they need to do. Let me drop it again in this class. There are 4 things that you need to do when there is an emergency, or there are 4 groups that you need to have when there is fire emergency, not just fire, any emergency. You need to have at least 4 groups. First one, we call them the search and rescue team. When there is fire, you must be able to, have a team that go for search and rescue. Whether the alarm has been raised or the alarm has not been raised, a team must, go and check what is really happening. A team must go and check if nobody is stranded. Search and rescue. Secondly, there must be what we call the communications team. That's the team that we call the 737 or 112 number if you're in Lagos. That's the team that we call 665 if you're in Ibadan. That's the team that need to coordinate with externals, with people that want to even render help. It's very key that we have the communications team. I'm talking of role assignments. 3, we need to have the firefighting team. So there must be a team that must respond to that fire. There must be a team that will respond to that fire, that will carry the extinguishers and go to the point, or drive the fire truck and go to that point and try, or go to the pump house and operate the fire pump, or roll the hose out, connect to the fire hydrant edge and position to extinguish or suppress the fire. Very key. And lastly, we have the team that does the head counts, or what we call the roll call. So when people move to the muster point, there should be some set of people that controls the traffic, that drive people to the muster point. And this set of people also does what we call the head count, or roll call, depending on what you do in your organization, depending on how you sign in. So it's again a disaster if we don't even know how many people are within the facility. It's again a disaster if we don't have a system, whether automated or paper, that tells us how we can account for people within that facility. I've worked in organizations where we actually have staff register. And you sign in, you sign out, right? I also work in an organization where you only use your card. So you tap in and tap out. I said the other one is sign in, sign out. This one is tap in, tap out. All right. So no matter or whatever we're doing, what we want is there must be a system. A system must just be in a place where we can have control over things that we do. Your fire prevention plan. You must, of course, have a fire prevention plan. The fire prevention plan, is more or less your risk assessment for fire, or risk assessment that is focused on fire, that states what activities occur on a regular basis and what we need to do, to prevent fire in those activities. So, for instance, if we work at height, then there must be, should I use the word instruction or safe system or procedure on how to ensure that hot work is effective and safely carried out. Even in the kitchen, in the workplace, when you use the microwave, you use the what called now, maybe electric kettle and what have you. We also need to have a system, where there is an instruction either on the microwave or switch off the microwave when not in use, ensure the water gets to so mark, or maybe ensure water is at half point before you start boiling. Ensure just little things that could allow people to, that could remind people about fire prevention. Then, of course, you then have the instruction that has to do it. In case of fire, switch off if you can. If you can't, find a way out of the building and press the alarm. That's if you have alarm panel. But if you don't have, what would they press? Not a problem. If you don't have, it's allowed. Let them shout fire, fire, fire 3 times. If you don't have a smoke detector, I can actually warn people. If I hear, as I'm seated now, if I hear fire 3 times, I know it's not a joke. If I just hear fire once, I may feel, or maybe they are just discussing and the word fire came into play. So that education, that communication, that information is key. Otherwise, we have an unbalanced system. Next slide, please. I've spoken about detection, right? So again, let me just emphasize that detection, so fire detection, especially using your smoke detector is key. Next slide, please. Testing and maintenance. So you have the detection system, which is the smoke detector. Some of us have even the sprinkler system. Then the next question is, how often do we check? Or better put, what is this routine for checking? Or because we just have this system, we just believe everything is fine. There's no need for checking. What routine do we have? What are the things? What do we do to ensure that there is check and balances? We are facility managers. Some of us, even the building might be new, just in everything, a new building. It doesn't matter. Smoke detectors need to be inspected by competent persons every 6 months. What do we inspect? We check functionality from the panel. We visually inspect that there is no damage to the panel, to the smoke detectors, and of course to the call bell, the sounder, and what have you. We carry out tests. Of course, information would have been passed to the workforce that when they hear the alarm, it's just a test, right? So we have that in place. Again, we have what we call a schedule, which is a routine. So it's not just a haphazard way of inspecting fire equipment. You have a routine. You have like a schedule, a maintenance schedule, where you know that, okay, every January and June or January and July, you carry out this, and these are the list of competent companies that can do this for you, and you bring them on board, or competent persons, right? For fire hydrants, depending on the system that you have, whether you have sprinkler, fire hydrant, what have you, if you can inspect them in-house, good. What do you inspect? For instance, for fire hydrants, stiffness of hydrant head, you know, you are testing the availability of water. If you have a fully functional, you know, fire engine or fire pump, there must be daily test running of the batteries. So most times it's powered by batteries. You know, so it's an electrical system. So you power with batteries. You know, some even have diesel engine. So you need to test. You need to test. You need to start those engines every day. There must be a checklist, sir. Somebody must run that engine for 10, 15 minutes every day in the morning. If you test in the morning, then for 15 minutes, then the following day you test, then you know that yes, the alternator is charging the battery and the battery is actually still in a good state. Then any day there is fire, you have a fair chance that this system will work. Otherwise, it's not going to work. Otherwise, what you just have may disappoint you. There could be need for us to have operational of either upgrade or repair, maintenance, and whatever. Yes, it's allowed. But if depending on the facility, so for instance, when I was in the downstream oil and gas, you want to carry out those critical fire equipment intervention, we have fire truck on standby with firemen. Those are good practices. We have people on standby, meaning that because when you disable, so imagine you want to fix something around the fire pump, even though maybe it's still functional, but it's not working optimally, and you decide to go and start work, and maybe fire then chose the day that you disable the you need to be able to see before it happens. You need to be able to imagine the impossible. Yes, how we in PwC. So you need to be imagine the impossible. You need to think outside the box, even though as it is now, it seems that everything is fine. There's what we call the what if analysis. What if it happens? You want to jump into your car. You want to start going home now. As you're about to go into the car, of course, you know that everything is fine as at now. But because safety is a state of the moment. Safety is what we call the current state. What is safe now may not be safe in the next 1 minute. That fire control that you have, what is safe now may not be safe in the next 1 minute. On the highway and there is brake failure. Of course, nobody is praying that there will be brake failure now, right? But when you are doing a what if analysis and you're saying what if there's a brake failure, then that means you need to not apply your brake, right? That means you need to even drive at a safe limit, at a speed where you can control the steering because you must not match your brake. That will then inform your decision to run below 100 kilometers per hour. It's not because you can't run. It's not because you can't speed off with the vehicle, but because you've done what we call the what if. You are about to position the fire extinguishers. What if fire happened in this room? Will I be able to use this extinguisher? That then tells you that, oh, let the extinguisher be close to the exit door, because if fire happens, everybody will go towards the exit. Some even put the extinguishers by the corridor, that's outside the space or room where they want to use it, provided that it won't reduce the walkway, because that will be under health and safety risks when people then hit their side or their hand against the fire extinguishers. So you need to do that what if analysis for you to then know what other thing you need to do. Then, like I said, you need to clean your detectors, you need to blow the doors and what have you. Next slide, please. Hi, yeah, so let's do it. So let's do it. Okay, so we said protect from corrosion. Most times these things even come in plastics, but of course the panel, most times is actually made of metallic material. Even if they write IP, that's ingestion protection rating of 67, 65, that means it won't allow water or dust to go in and what have you. You still don't, that doesn't still give us the liberty to go and install this under the rain, to go and install the panel outside the building. So we still try to install the panel within the building, shield it away from external weather like dust and rainfall, just to make sure that we protect it from corrosion and of course mechanical or physical damage. So where you are having the forklift and those kind of equipment that maybe in the warehouse, you won't then go and install your panel close to where it could be damaged or impacted. Facility managers, it is key that you give these jobs to people that know what to do. Health and safety, yes, looks like a good business, but it's not a business where it's not a business for us to do business. Health and safety is not where we should then give the task to our friends to say, oh, this person is my friend, let me give her the job or let me give him the job. Because it is critical. Things can go wrong that could affect even the future of the unborn generation. Next slide, please. Okay. Here we're talking about the response time. The response time, all we're saying is speed of evacuation. If fire should happen, how long did it take you from leaving that building? Or how long should it take even your co-workers from evacuating the building? Now, this is not cast in stone because of complexity and what have you of different buildings. But what we try to do if the building is actually large is for us to have, different muster points or called fire assembly points, so that people don't struggle to make use of the same staircase because the elevator will not be working at that time. People won't struggle to make use of the same exit way, and there won't be stampede, and of course, there'll be improved response time. So I may ask you, have you identified the emergency exit points? How often do you inspect the emergency exit points? How aware are your cleaners, to know that they should not block the exit points? I've been to facilities for inspections where cleaners are, so maybe there is a small corridor just after the exit point, exit door, and that's where they will now put the I won't call it office, sit out area of the cleaners. Let me shock you, facility managers. Cleaners are very important elements or factor to your success as an FM. You may decide to handle them with iron fist and just be the Margaret Thatcher of, oh, do this, do that. But the truth matter is they're just doing that to earn their salary. No. Cleaning should be treated with dignity. I'm not saying you should go and build an hotel for cleaners, but I'm saying that even when we are allocating space in the facility, cleaners and security men are key. In fact, in facility management, when we are planning for emergency response, the ever-present people are the ones that we select and we prioritize. And who are those guys? The security men, followed by the cleaners. In some facilities like where I work now, there was a day I stayed over in the office, so I was in the office till the following day. And around 2:30 a.m. or thereabout, I noticed that the entrance door to the main office opened, and a security and a cleaner walked in, and they came to clean the office ahead of the next day, and I'm like, oh, so because I've never seen them come in the morning to clean, so I usually wonder if it's actually ghosts that clean the office overnight. But that day I realized they weren't ghosts, the human being that come at 2:30, 3 a.m. to clean the offices. And when we want to have fire safety training, these are also the guys that we try to bring in, because when fire happens, you and I will not be at work. Most times we run regular hours. And by regular hours, we mean most of us do 8 to 5 or 8 to 6, worst case. And some of us are workaholics, so we do 8 to 8, not a problem. But some people actually run shifts and they will be here till daybreak on a back-to-back basis. So we need to treat them right, and we need to train them. You need to understand that until people know how they can prevent fire, that's when you can have a bit of rest. Fire detector, so there's what we call the NFPA 72 standard. NFPA stands for National Fire Protection Association, USA. National Fire Protection Association. So they've got the fire codes, the fire safety code. So for buildings, for automatic sprinkler system, it is called the NFPA 13, NFPA 13. For the signaling and alarm system, which is the smoke detector, is called NFPA 72. So it is not okay. Yeah, is here. Then of course NFPA 10 is then used to to inspect. It covers the fire extinguisher standards. So they are a bit of should I say a mix. In Nigeria, we adopt some form of American and British, safety codes. We try to mix them up. So what I mean is, for the design, we do the NFPA. So NFPA 13 sounds. So if you check the design that the engineering team would have done, whether the consulting team or you're having that building in place, so I've been done based on the National Fire Protection Association code. But for fire extinguishers, for instance, and classes of fire, blah, blah, we actually use the UK code, UK safety code, the British standard. So there is that mix where we are doing things. But for inspection, so because the standard, so you need to inspect based on the design standard. So because the standard was built almost globally based on the NFPA standards, so because your fire design was done based on NFPA, then your inspection should also follow suit. Then your inspection should also follow the NFPA and what have you. Okay, and the main cost, the main benefit of having this inspection done is that it will ensure that there is safety and reliability of the equipment. When I say safety, that means that because you understand that this thing is functional, then you feel safe because the space is safe. And then secondly, when you need to use the equipment will answer. They will respond to you. You will call them and they will answer you in the days of trouble. That's reliability. When you call and it answers, that's reliability. So by definition, you say reliability is the degree at which an equipment, item, machine, or what have you will function in relation to its design factor. So if something is supposed to, by design, it's supposed to function every time, 10 over 10. And it functions 9 out of 10 times, 9 over 10. Then the reliability is 0.9 or 90%. All right? So then by engineering, I was told that if you want a system to be reliable, you lay the safeguards, the controls or the safeguard, you lay them in parallel and not in series. What do I mean? layer of protection. You need to ensure, so if you have extinguishers as against civils, how do I explain this? Okay, so if you have 50 kg, oh, fantastic, thank you. If you have 50 kg DCP, that's dry chemical powder, you know, that means you have, so you can actually have 6 kg. So let me use 25 kg for ease of maths. So if you have 25 kg dry chemical powder cylinder on wheel, it exists. You put that in your generator house, right? We are saying that the reliability of that 25 kg is embedded in itself because it only has one control, one operating control. Meaning that if that control or if there is a problem with that 25 kg, then it is as good as useless. But if you have them laid up in layers, and that's what we call parallel. So as against having 25 kg of DCP, you now have 4 numbers of 6 kg. So you now have 6 kg in 4 places. That's 6 times 4 is 24. So it's as good as you also have 25 kg of DCP. So what we know by maintenance and reliability MRR is to say that if you give me 4 numbers of 6 kg dry chemical powder, I feel safer, and I'm in fact safer than when you give me just one 25 kg DCP. However, if that 25 kg DCP functions as designed, it will last longer at one shot. But the 6 kg, you need to finish using one, then pick the second one, then pick the third one, then pick the fourth one, right? Same thing with fire safety. Reliability is key, and you need not to depend. So instead of depending on one smoke detector or having all the smoke detectors placed on one panel because we want to save cost, who will say, can you, instead of having 8 zone panel, and on each zone you can actually, so on each zone you can actually wire like 3, 4, or even more locations. So let's just say 4 locations. So your warehouse can be on one zone, maybe your quality lab under zone. And so if you now have all these zones, all these different, so by the word zone, I mean different departments, maybe they are separate. You have the open office, you've got the lab, you've got the health and safety, you've got the engineering, you've got the procurement and supply chain, and all these things. And you now loop everything on one 8 zone panel. Sir, if that panel should fail, all those places are exposed. If that panel should go bad, then that means everything is bad. But if you rather do 2 numbers of 4 zones, then the possibility of having those 2 going bad at the same time is low. Reliability, right? So we then say that what can you then do to ensure that your system is reliable, right? And lastly, we say that this helps to prevent losses. So when you ensure that your equipment are tested, are inspected, and they are functional, then loss reduction happens. I can see the screen again, please. If you can hear me, or is it for my hand? I can't see the screen, sorry. Can someone share? So I don't jump the slides. Hello, can you hear me? Hello?
Yeah, we can hear you, sir.
Yes, please, can you share that screen?
We can actually hear you, sir, but the screen is not.
We can't share from, it's only the host that can share the screen, sir.
Yeah, so I'm talking to Max-Migold. I'm not in Max-Migold office as I speak. So can someone, let me see. I'm actually a host, and I can't find, like seriously, I think Max-Migold has dropped off. Okay. Do you have the slide? Who can share the screen for us? Or let me pick up the material. 1 minute. Okay, Esther is at the waiting room, so let me admit her. Esther, please, can you share the screen? You dropped off.
I can share tomato.
Hello. Can you hear
One
me?
class.
Please, can we go on mute? Hello, please, can we go on mute?
Gbé rẹ́ẹ̀dì yẹn sísàlẹ̀ kó dẹ̀ tẹ kinní yẹn lásán.
Mr. B, please go on mute. I'm trying to the material. Mr. B, please go on mute. Esther, please, can you reshare the document? Let me make you host. No, let me make you co-host so you don't lock me out. So Esther, you are now the co-host. So I can see back on this call. I think I need to solve my problem myself. Okay, I can see the screen now. Okay, so next slide, please. Okay, so this is just again is indicative. So your business may have maybe more stringent requirements as regards frequency of inspection. So but here we're just saying at a minimum, ensure you spend the fire extinguishers every month, ensure you service the fire extinguishers every 6 months, ensure you conduct allostatic testing of fire extinguishers every 5 years, ensure you have the annual comprehensive check of the mechanical parts, the nozzle, the hose, the vessel itself, that's the cylinder. Ensure that at least the condition and the amount of the extinguisher agents, that's the chemical, the CO2 or the foam in that extinguisher is checked, by competent person. For the fire fighting system, fixed equipment like the hydrant, the hose, ensure that on a quarterly basis, every 3 months, recommended that you inspect. Some people do this every 6 months, but please ensure that these inspections are done. Next slide, please. Okay, so it's just legal requirements. So we're just talking about the legal requirements for Nigeria, for UK, and for US. Okay, then we have the regulatory reform fire safety order, RFS 2005. I said initially that we had the National Fire Safety Code 2013, which each state is supposed to comply. That's where they then extract their conformance authority from. That's why they can then come to your building and say, yes, they need to check. Next slide, please. Okay, so you can actually read this up. So this is actually for the US code. So using the OSHA 1901.35, clause of the OSHA standard, to inspect the building for fire safety. So OSHA is actually US. Go ahead, please. Next. Okay. So some of the recommendation, for OSHA, from the OSHA is to say, you must have, depending on the building, you must have exits, you must have exit door that is unlocked from inside. So exit door, most times you can't open from outside, but you can push out from inside the building. So we recommend that your exits should have an exit door. Again, most exit doors are fire retardant, fire retardant, so they don't burn quick for up to 2 hours. Then most times, they, not even most times, all the time when they install, they should open outside or outdoor. I mean, outways. The exit door should open outside the building so that you can just push when you get to that point. Then the emergency light must be maintained. The emergency light must be installed. And there are two types of emergency lights. UK standard will tell you that there is the maintained electrical emergency light and there is non-maintained electrical lights. So the non-maintained is the kind of light that you have that only comes on when there is power failure. That's when that light will just come up. But the maintained is the one that is also lit. So you won't even know that it's an emergency light, because when you power on when you switch off the socket, the switch rather, the light is on. But when the light goes off, then when there is power failure, some lights then stay on. Those ones that stay on are then the emergency lights, and they are called the maintained illuminator. So you need to, whether it is maintained or not maintained, you need to ensure that these emergency lights are actually functional. And there is direction. So there is functionality, there is direction, that's with directional, and the procedures need to be clear. Next slide, please. Your fire prevention plan, I think we've seen this before, must be written. So don't tell me that you have it offhand. No, that's be written. And everybody needs to be aware of this. So in your HSC meeting, in your town hall meeting, in your external communications, in your internal communications, you need to be able to, let people know the actions they need to take in case of fire. Next slide, please. So minimum requirements, what should be contained in your fire plan? As of today, all your major fire hazards, how fire can happen. So you need to know that, and you need to write it down. Then how you will handle hazardous material that can actually result in this case, fire, not just spill or what have you. So you need to have this. You need to then know how you want to control accumulation. Some of us in our facility just have the waste points, the debris collection points is overfilling or is overfilled already, and they were not even reacting. Which is fine. So we say we should inspect and maintain all this, which is fine. Then what again do we have there? Personnel, yes. So your emergency response team, people must be able to know who they can walk up to when they have complaints, and not just when they have, or not just when there is fire. All right. Then you need to ensure that that document is a living document, meaning that you need to review. When new things are being added, you need to, to review. You need to update. Next slide, please. Next slide, please. I can't see the next slide. Sorry. Hello. Okay, I think I need to share myself. Can you see my screen? Can you see my screen, please?
Yes, yes.
Okay, so let me just share. Okay. Okay, so conducting the inspection. So when you want to inspect the fire extinguisher, these are the list of things we said you should consider. The accessibility, the pressure indicator for DCP or the weight for CO2, the pin and the seal that are sending tags, the eligibility, is if the eligibility, then service date on OS and things like this. So then, of course, installation heights. Consider the height of the people around you. So don't go and install consider the height of the people around you and use that to judge yours. Next slide, please. Oh, sorry, I'm even the one. I'm even the one controlling this. Okay. So we said something about this extinguisher schedule, inspection routine, the legal requirements, yes. The fire, yes. This, yes. Okay. Must be everything, yes. Elements, yes. Okay. So again, I think we've mentioned something around the detection system. We say that you need to ensure that you install smoke detectors in your house. So it will make sense, even in the office, in the house, it will make sense for us to be able to, detect early, and we can then respond early to the issue. Then we said testing, all system must be tested and adjusted. By adjustment, I mean you actually updating and putting in the corrections and what have you. So it's not just about testing the system, but also that system, you need to update that system. You need to put in things in place so that the system can work as it should. All right. Okay, talking about this, as well as response time, location, like I said, for location, it should be in line with NFPA standard. So by location, so the standard tells us that for a 9 by 9 square meter, so for 81 square meter, you should have one small detector. So if you don't have, no, but again, then the design tells us that if we have bin, that can obstruct the horizontal flow of the smoke, then you need to treat those spaces as different spaces. So again, it's not just about you having this detection system. You also need to test and be sure that the detection system captures or covers correctly, the complexity of the space. So I'll just advise that you speak to people that knows. I'll advise you just speak to people that knows. Otherwise, you would think you're doing the right thing, and you're actually off key, so to say. Okay. So I said for the design, just speak to people that know and
stay out of trouble. All right? Because when there is the fire incident, the question is who did the design and what was the competence of these people or of that person. Okay. So this again fall behind what we're saying. So the acceptance tests they're doing has to be done again by competent persons. So there are the static tests where you pressurize the cylinder bottles, the underground connection, depending on if you actually run your pipings underground, just ensure that you've done your big game and nothing is. So it's just about pressure test. So if you do your pressure testing and you're not getting the right pressure, so in a closed system, what goes in should come out in a closed system when there's no leakage. So if I put in a 4-bar, a 6-bar pressure through the piping system. On the other hand, so if it's locked, so you have the gauge and what have you installed, I should be able to read the gauge to say, yes, I still have my 4 over 3 days. I still have my 4-bar, my 6-bar intact in the pipe. But where we don't have that, that means that there is leakage somewhere or something is just wrong. So you need to allow the competent persons to do this. Okay, so your sprinkler system, you will see the bulb glass. That this red bulb glass, I said, okay, it will break by each. Okay, your emergency plan. So there must be emergency plan. There must be, just like the assessment that we did, we need to understand what can be likely, how seriously, what can we do, who is exposed, and things like that. Let me pause to take questions for maybe 5 minutes, then I hand over the class. Thank you. Questions, please. Questions, please. Hello, class. Can you hear me? Yeah, Udwa, Godwin, please go ahead.
Good evening, Mr. Oladis. I just want to quickly ask on fire pump, because at times trying to get this firefighting system installed is always good, just like the NFPA standard, working with measurements, working with best practice. How would I ascertain the best size of pump for a plant of possible that 2005 square meters or 5,000 square meters? Is there always a data sheet for ascertaining best standard and practices based on NFPA standard?
Yes. So to answer your question, yes. So there is not even NFPA. So there is there's pump selection. So before you can select a pump, you need to, of course, like you just said, you need to know the floor area of that space. Then you need to know even your location of positioning of your firehouse. So from there, and then the pressure at which, because again, depends on the distance of the hydrant, to the possible point of fire, which is the building. So all this, you have all this information. So before you then design what size of pump, of course, so the diameter, which is the size of the pipe that you want to use, the floor area that is going to be covered
and some other information that has to do with the pressure that we expect out of that system, of that suppression system. And that would then give you, an indication of the pump size that you need. That won't one, burst your pipe, because if the pressure is too much, that your pipe cannot even withstand, forget it, you're going to lose that pipe. So that is key. But like I said, it's NFPA standard. So if you can Google NFPA 13. NFPA 13. I think there's the 2021 standard, that's revised edition, and you can see. But the truth is, your pump suppliers, so the NAFCO of this world, if you supply the information that you need, they are going to, that one that NAFCO supplies the engine. That's the fire pump itself. So if you give them the information, or you contact a NAFCO Dubai, they will tell you what pump you need, and and help you with that design. So I think the key thing is having the right person design your system. Of course, that design is dependent on the information that is available. So they ask you many things, and if you answer correctly, then they will tell you what pump size. So that will even tell you the power required to drive that pump, and and what type. So you may even need to good for you. If it is diesel engine, you need to just find a way to make sure that the pump is operational, like it's powered. You get. So I think the good thing is, one, there's a standard, and two, there are competent persons, and three, there are even manufacturers. So we speak to the manufacturer directly, we get all the information as well. Thank you, Mr.
Yeah, thank you very much. I just wanted to confirm. I just wanted to confirm, please. Does when the client says mobile fire pump, is it compulsory that it must come with tire and casters, or it could still be stationary?
If it's stationary, that means you need to provide another vehicle that will pull it. If it's stationary, that means you need to pull it. Or if it's on wheel, tire, the effort to pull or push it to the point of need is reduced.
Okay, because the client says mobile, but the OEM is providing one without tires. Is that still reasonable?
Yes, but the OEM has given you additional work, which is you need to have an e-locks that can hook to the equipment and drag it to the point of use. So the person that said he wants mobile does not understand that fire can happen anywhere.
Okay.
So you need something that can move to point of need or point of use.
Okay. Then it could be.
So if you accept fixed from your OEM, all you need to do is to provide a means of moving that, which could be an e-locks. And if you have that explanation for the plant, it should accept that explanation.
Okay. Thank you very much.
You're welcome.
I wanted to confirm, are you on the group?
No. Am I?
Okay.
But, am I on this group?
No, sir, you're not the group.
Okay, please, could you kindly share me your contact?
Okay, so my name is Kolakbo Bolade, as I introduced at the start of this defense. So you can look up for me on LinkedIn or something, and we can.
Okay, I'll get you.
Okay.
Thank you.
So so as I wrap up the class, is around your emergency response. So if you actually flow with me in this class, you realize we've spoken around the prevention, around the suppression, all right? We taught the protection, which when I mentioned that you need to, have the right structure in place. But one key thing is the response or firefighting. So you need to have fire and emergency action plans. In case of fire, what should you do? I used to pass through BOC gases in Oshodi just before. So we're coming into Oshodi from wherever. I don't really know. Okay, so we are coming into Oshodi from is it Solo? Yeah, so we're coming from Okota or Solo, and you're going into Oshodi. So just after there is a military, I don't know, is it a barrack or what have you? But just before that, there is BOC gases. And the first time I passed through that place some many years back, what caught my attention is what they wrote on their tank, which is, in case of fire, do not use water. So I think that experience should still be there. No, most of us, when there is fire, is water. But an oxygen manufacturer, I said that in case of fire, please do not use water on this tank. I've not had the opportunity of asking anybody what is stored in that tank, but that information is instructive enough. What do we mean? People must know what they can use and what they cannot use in case of fire. In case of fire, don't use water extinguisher on electrical panel. In fact, wherever facility I have opportunity to manage as regards health and safety, one of the first things that I do for fire safety is to have the fire extinguisher audit done. That's, I want to know the number of extinguishers that we have, what type of extinguisher, where is their location, when is their due date for servicing. I just ask the guys, the HS officers that I have or supervisor, that I need this information in 2 days. So comb this factory or comb this workplace and comb this facility and give me this information. And one of the things I do is take out water extinguishers. And why? Because I'm dealing with people from diverse background, of diverse safety consciousness and what have you. If you position a water extinguisher close to an electrical panel, and that guy sees that there is fire or smoke smoldering out, coming out of that panel, he will possibly use the extinguisher that he sees closest. So anything is very close to the panel, he will then go for it. And in this case, if it is water, the guy, I can bet, will get electrocuted, because he'll be spraying water on electricity and there'll be that conduction. The water is a good conductor, right? And it's going to be electrocuted. So we're going to have another emergency, which will be medical emergency. In fact, for you to have a workable, an effective fire and emergency response plan, we do what we call the threat analysis. When we say threat analysis, we're saying, can you identify the emergencies that can even occur in your workplace? So people tell me, so most time when I go to facility, so I do facility, safety assessment, that's Max-Migold, and when I go there with Sida, architect Paul, everybody, or what I mean, and so some of the things that we see is that most companies, workplaces, facilities only identify fire and maybe medical emergency as their threat. So some are, especially on the highland, you've got threat of flood. Some have got even threat of security threats, so intrusion. Some have got, there is one facilities very close to toll gates that when I say toll gate, I mean like toll gates, and during NSAS, they realize, they've got these threats of civil unrest. So some have got even threat of robbery, so I come into your facility, your warehouse, and when we do the facility assessment, I can see the broken fence, or the fence are not too tall, there are no physical surveillance in place, there are no automatic surveillance like CCTV there. So if I conduct that threat analysis, then you know that your problem is beyond fire and medical. That means somebody, if you are in the north, they can actually intrude, so that somebody can actually come into that facility and cause some notable harm. In 2017, I think late 2017, when I was safety manager for MBC, in Kano. We had a gate, and the gate was not strong enough. So the gate is just outside the main premises, but we're also the owner of the other facility or the other premises that has a broken gate. And we've written mails, we've pushed with the facility managers. Nothing was done until there was an attack. So intruders came and somebody was seriously stabbed. So the security guy guarding that place was seriously injured, head cut and what have you, because the robbers want to actually steal the welding machine. So we actually, I think we're building a new water storage tank, and the contractor has got some machine, some cable. And robbers, well, that time it wasn't bandits, so I can still use the word arm robber. They came and they injured, they macheted that guy on his head, nearly killed the guy. It could have been a fatality. Yes, I was the safety manager, and I can actually show evidences that we've spotted this, we've shouted, we've gone to the meetings, we've made some noise around this, blah, blah, blah. But that was not enough. Today, I will shut down that place. I will shut down that space. Today, with maybe I won't use the word confidence that we've got now, but with the development, the growth we have in the industry now, I will shut down that location. If it's not safe after some timeline, we say, oh, we are sorry, nobody can, man this place because the gates are broken. But I give it to, I put it on the table. Facility managers are culprits when it comes to these things. If your AC is not working in the office, you tend to fix them or fix it or fix the ACs, depending on how many ACs we have. You tend to fix the ACs or your own AC as quickly as possible. But when we have security threats, when the gate is broken, when there is no padlock to lock a safe, we tend to then follow the due process, right? I'm not saying you should not follow due process, I beg your pardon. But I'm saying that we can actually fast track the process. You can actually make some noise around the briefcases or obstacles, the challenges you're facing when it comes to things that are threatening the threats. So I want to say this as I wind up, that beyond fire, what are those threats that you can see? Can your premises be intruded into or invaded by bandits or by whatever this night? Illumination problem around the facility, around the premises. Lack of control or loss of control. Is there a tiger roaming around in your facility? And by the word tiger, I mean, is there anything that can cause harm? Is there any danger that your people are exposed to? You're at home, chilling. Nice one. You've walked and that's all you need to rest. Right? But is there any exposure you left behind? Please, as you go back in the morning tomorrow, address these things. The quality of life we give to our people as facility managers is not for whom we have today, but I always say, let posterity judge me. Let the future generation come and look back at what we've done and pass their judgments, whether we didn't try our best in the context of the resources that were made available to us at that time. The severity of the fire, if it happens, the hazard that can cause that fire, the possibility of that hazard causing the fire, the number of persons that will be exposed if that fire happens, the controls, the training, information, fire extinguishers, suppression system, things you have in place to resist the fire, and the contacts, the response time to, or the availability of medics. So for your emergency response, it's not just about the clinic, which is the medical department. You also have the security guys. So as I speak to you, do you have on your speed dial, on your phone, do you have number of hospitals that you can take your guys to if there is an accident? Do you have number of security or police stations or security operatives that you can call and escalate to? That was the only thing that saved ShopRite Ikeja during the NSAS. What I read was that the FM, the facility manager, called of Mesa because they have good rapport, because he has, not just because of the incident, he had made friends with Mesa Ikeja before that day. So was able to have one or two numbers he could call and say, I'm under lock and key. I'm about to lose this space, this facility. And they responded. What do you have, even in terms of the in-house training that you've given to your people? Please ponder on these things, think about them. Fire in the UK, we say, oh, we have the 5 classes. Class A, which is a solid, class B, liquid, class C, gaseous, class D, flammable melters, class F, animal fats and oil. Then, of course, the silent or the non-existing class, which is fire due to electricity, is not a class of fire. It's just due to its source of electricity. These things are there. For class A, oh, what SQL should we use? All these information are inside this document, this slide. You can read up. Your DCP, also called general purpose chemical powder, can work for class ABC. So you need to have that. I said eliminate water extinguishers because you don't want to have people use that on electrical panels. If you work in filling station or fuel station, downstream, or what have you, you must have class F kind of extinguisher. So your chemical foam, your wet chemical foam is key. And that wet chemical foam, so class F will tell you about the restaurant and the kitchen and the hotels, restaurant, hotels, and kitchen. When class C will be telling you about the gaseous liquid, the gaseous, and class B will tell you about the liquids. You need to have your discipline that are important to you. Please, time is fast spent. We need to have that action plan, and I wish us all the best. Thank you. Any other question for close class? Please, 10 minutes past 7, so we are 10 minutes behind schedule. So do we have one or two questions I can just respond to, then we can move on. So in Neka said, Neka Bona, good evening, said that as in a long corridor, is there an allowable distance between 2 fire extinguishers? Yes, please. Again, it depends on the type of the extinguisher that you're using. So in this case, let's say class B. Then it depends on the weight of the extinguisher. So a 9 kg extinguisher, so I can share, so now British standard. Also, I can share maybe that information. So when I get home, I hope I have the material handy. Okay, so I can actually look at the material and share that information around distance between extinguishers based on their size. If I don't see that, then I will look at my NSC Manager Set of Engineers project. I think the point I did was around this question that you just asked about there. So I can around the number of extinguishers based on the capacity of the extinguisher. All right. So Neka, I'll send a response to Baraka and she'll be sharing it. Thank you. Any other question, please? Oh, somebody is using up his hand. Uduak, you've spoken like twice. Can we hear the floor to another person?
Just lastly, please, based on the concluding part, please. Just lastly, I'll be quick on it. Due to the high cost of these fighting systems, how could facility manager introduce this to management so that they would know the importance and usefulness?
So you need to do your risk assessment. So it's a business case. It's a business case, really. Some things are basic. So extinguishers, I don't think you need to justify extinguishers, But when you then want to bring in things like FM200, your sprinkler system, then you need to build a business case. What do I mean? You need to do a risk assessment on the existing hazard, how likely, how seriously, what will be lost in terms of revenue and in terms of even cost of repair. if that accident should happen. In fact, if there is an occurrence in similar industry in the last 3 years, you need to showcase that, you need to bring that on board. So for instance, if you manage an hotel, say maybe the Best Western or Radisson Blue or what have you, and maybe some things are not in place, it's easier to then look at the the hotel in the hospitality industry and look at, okay, what has happened in the past. So if you take the case of Ebano supermarket, or which one happened in Lagos, in Abuja, recently, and let's say you work for Post Charis, for instance, and you have, you need to actually protect valuables. So you can cite incidents like all those, warehouse fires and what have you, and make a defense of your proposal. If you work for a real estate, there are all these market fires and what were lost. So some real estate actually manage some very extensive shopping mall and what have you. So you can actually, so you need to do your risk assessment. You need to look at what has happened in similar industry. You need to look at what will be lost if this then materialize. Then you come to conclude that, okay, this is the cost of installing the system. At times, I don't like the insurance guys, so because I do safety, and at times I will look at how much am I losing versus how much am I using to protect what I'm losing. So if it doesn't make sense, then, so when you ask me to insure something that I know that I can always buy, if I lose it, then I'll maybe reluctant, you understand? And instead, I want to play safe. But for you will need to justify that, okay, we can spend 10 million to protect 200 million. It makes sense. But we're asking the guy to use 100 million to protect 200 million. And insurance is saying, if you pay 5 million, they can pay back that in bonds. The guy will go for the insurance and not for the safety. So we need to, be fair in the pricing or the cost. We need to call out the benefits. You need to let the business understand that, yes, insurance can actually, pay us, but there will be lost revenue. The money you're going to lose when you're trying to rebuild the factory is not going to come back. If Coca-Cola factory burns, people will start drinking Pepsi. They won't stop drinking Coke. They won't stop drinking soft drinks. So it's not that they won't drink Coke. They will drink pop cola, anything cola. So is that lost revenue that, again, you may need to also call out and speak to. Thank you.
Thank you very much. I really appreciate it.
Yeah. So is it fair if we call it a day? But please, you can. So my name is Kola Kobolade. So you can always send me a message on maybe on LinkedIn if you have any further questions. But you just let me know that you are from Max-Migold, so that I can respond, on time. I respond to everything, but the speed of response again matters. So just let me know if it is for me to give you a call or something and explain, or do a voice note, whatever it is. We're here to support you. Thank you so much. All right. So Esther Barakat, over to you, please.
Thank you, Mr. Kolapo. Thank you so much.
Thank you. Esther, you about to say something?
Thank you so much.
Okay, thank you, everyone.
Thank you, sir. Thank you, everyone.
Thank you. Thanks for your patience. Thanks for your cooperation. Thanks for your understanding. Thanks for your time. Thanks for your money. Thanks for everything. All right, see you some other time. God bless you. Bye.
Bye.
Bye. Good night. Thank you.
Nice night.
Yeah. Good night. Good night, Oza.
Good night, everybody.
Good night, everyone. Bye.